you. So thank you guys for being here. So today we are gonna talk about continuous delivery of microservices for Kubernetes. A lot of buzzwords to catch attention. So let's start from a lot of years ago. Who here is working in Agile projects? I think most of you. And what is Agile for me? For me, Agile is, if I can just summarize it in a word, it's just about a quick and continuous feedback loop in order to basically to adapt quickly, in order to deliver, let's say, value to the customer as quick as possible. And actually, we can already see in the Agile manifesto where everything started, so 17 years ago, where basically thought leaders in the software industry, they just gathered together and they tried to discover ways how to develop software better. And if you can see here, the really first of the 12 principles is already talking about continuous delivery. And maybe it's not the same as we mean it today, but they had already a rough idea of this stuff. But if we think, and I think all of you can agree, what do we see actually in the projects? What does a project look like? For me, it's something like this. It's like war. It's gunfire, it's smoke, people dead on the floor, heroics and stuff. Why? Basically, most of the time, I still see big bang releases. I think not so many people are delivering multiple times per day. You see often manual deployments, manual testing, a lot of us having to work overtime or during the weekend. Here, so what's actually is lacking is automation, in my opinion. And if we think what has happened in the last few years, it's actually pretty a lot, in my opinion. So we have seen revolutionary changes with the rise of containerized applications, then container orchestrators like Kubernetes in order to manage containers at scale. And this new stuff is actually awesome. So I would recommend to everybody actually working with something like Kubernetes. It kind of turns us in Google ninjas, in my opinion. But as usual, we have a problem. We try to solve this problem. We come up with solutions. But these solutions bring new problems. And so we have also new challenges with containers and container orchestrators. If we think about a middle or a large-scale project, we have to set up Kubernetes, and basically it's pretty tedious to do that manually or with scripting. We have to containerize applications, so generating basically Docker files or something like this. We have to deploy those applications into Kubernetes, for example, so we need these YAML files, so the so-called manifests. And still, we have to set up CI/CD, for example, Jenkins, configure everything properly, configure that Jenkins can talk to GitHub, and so on. So also connection to other systems, artifact repositories, and stuff. And boom, I think it's actually pretty complex. So that's also my experience, what I experienced by customers. And actually, I think we forget something here. It's really cool, shiny stuff, but what about delivering business values? Because at the end of the day, that's what we're paid for. So that's where Jenkins X comes. Jenkins X is an ecosystem, for me, built around Jenkins, which targets Kubernetes as the platform to be used, let's say. It's heavily inspired by the Accelerate book and the State of DevOps reports. And really, this is an awesome book. I would recommend every one of you to read that in order to achieve high-performing software organizations. And basically, based on those principles, what are the Jenkins X capabilities? It helps us to set up a Kubernetes cluster within, let's say, 5-6 minutes from scratch on a cloud provider of your choice. The best one at the moment is the Google Cloud Platform, just because it's more tested. But you can use also Amazon, you can use Microsoft Azure, DigitalOcean, and many more, actually. So from time to time, probably a bug comes up, but actually they are using Jenkins X in order to basically deliver also Jenkins X. So it's moving pretty fast. After installing the Jenkins X ecosystem, you have a bunch of developer tools already installed from scratch. For example, an artifact repository like Nexus, like Artifactory. You have an internal Docker registry. You have Jenkins and many other tools that we will have a look at them. Of course, Jenkins is properly configured in order to talk to Nexus, the Docker registry, Git, and so on. And we have the nice new buzzword GitOps in Jenkins X. So basically, all the environments are set up through Git. So everything is managed through pull requests. So with environments, I just mean staging, production, testing, whatever you have. Everything is defined in code, like the application code. And of course, why did I use at the beginning the title end-to-end automation? Because it doesn't just target the outer loop, so after pushing code into the repository, but also is targeting the inner loop. So when we are working at our machine, so for instance, we can generate projects just with one command. And yeah, that's it for a small introduction. So now I pray the demo gods to be with me. So basically, I already generated a Kubernetes cluster just because I have 45 minutes. And actually, at the beginning, I wanted 2 clusters, but I realized one was enough, so that's why I still have backup in the title, but it doesn't really matter. That's a name. So let's see what has been, all this stuff has been installed basically by Jenkins X. So important to see, I think, you can see the Docker registry, so it's an internal one. You can see a Nexus artifact repository over here. You can see also Monocular and Chart Museum, which are, let's say, artifact repositories and graphic user interfaces in order to visualize and store Helm charts. And in case you don't know Helm, it's just package manager for Kubernetes. You can think about Brew, Yum, something like this. And of course, you can see Jenkins itself. So there is a bunch of stuff that can help us to basically develop projects. So basically what I had to do, and here is actually also my backup in case the Wi-Fi doesn't work. So I just had to basically type JX install. Probably it's a little bit small here, but in order to install on an existing Kubernetes cluster, I just had basically to type this command and then use this nice user interface, specifying we are using a Google Kubernetes engine. Then it's going to install a bunch of stuff like Helm, the server-side Helm called Tiller, and a bit more stuff. So it's going to create a load balancer, L7 load balancer, and associate an ingress to it, and so on. So basically, you end up in this situation. So in here, with all this bunch of tools installed. And basically, we can already see, we talked about also environments. So staging and repository and production. So for example here, so it was just created yesterday. You can see a staging environment represented by a Git repository on my local GitHub, and production. And also I have a small demo application, but we will create also a new one. Let's see how far we can go. All this information can also be seen. I hope it's big enough. So from the back, can you see, guys? Or shall I make it bigger? Bit bigger? Let's try. I hope it helps a bit. Okay, so here we have also a command line interface. So we can see the environments we just talked about. Okay, it's not so slow, the Wi-Fi. So we can see a staging environment. We can see a production environment. And important to notice here is the promotion column over here. So you can see staging is automatically promote. So stuff, when you develop microservices, they are automatically out of the box. They are deployed to staging. Whilst production is a bit more tricky, we would like also to achieve continuous deployment, but for the moment, not everyone is ready. So the default is manual. So it has to be basically triggered through a command or a pull request, because we are talking about GitOps. And we can also see all the predefined pipelines defined for us. So we can see for the staging production pipelines on Jenkins, and we will have a look also in the CI server, and just a demo app I created yesterday to test. And basically here you can also see the URL, so you can directly jump to Jenkins. And actually there is also one nice way, so you just type JX console, and we land into our shiny Jenkins instance with the blue ocean interface. At the really top, you can probably see I don't have a domain name, so I'm using the magic nip.io here. And as we said before, we have a staging environment, so a staging pipeline, and a production pipeline. In other words, everything we deploy is actually triggered through a pull request. So everything, every microservice, every, let's say, application infrastructure we have is defined as an Helm chart, basically. And it's pretty nice because Jenkins also installs webhooks for us on staging and on every repository. So here we have everything already set up out of the box, basically. Okay, and if you want to see more tools, actually you just type JX open, and we can also see, for example, Nexus, we can see Monocular, we can see the Docker registry, which normally has some kind of problem in generating DNS entries, so normally it's not really reachable from outside. But for example, Monocular should be reachable. And here we can see, for example, some application I deployed for testing. Okay, so now, since I'm a Spring Boot guy, I will try to generate a Spring Boot really simple microservice. And in order to do that, you can use the JX create, in this case, Spring. And I can choose the language, so even the new shiny Kotlin, but let's just keep it simple. So I will choose, for example, Java, and JDD, awesome. Now, we will be using the actuator for health checks, which are going to be called by Kubernetes for also self-healing mechanisms. We have a web application, just not a reactive one. So let's include Spring Web. And for the moment, maybe I could even include, for example, Lombok. You have a lot of stuff, and as you can see, you have a bunch of libraries which you could use, even the new Spring Boot admin, Spring Data, everything you want. So in-memory databases, and so on. But at the moment, we don't need so much here. So we can just go on. Hopefully, everything is working. So yes, I want to use my GitHub. So basically now what's happening under the hood. Here, Jenkins X is just delegating start.spring.io, the normal Spring initializer. Hopefully it's not too slow. And basically it's also initializing a Git repository locally. And now also pushing the repository on GitHub. So it's going to take probably just a few seconds. And yeah, that's it. So we have already a Spring Boot microservice, which I can monitor. But first of all, so you can see here the folder has been generated. So let's go inside here. OK. Now, basically, what happens? So Jenkins is already building our microservice, and at some point later, it's going to be deployed, basically, automatically on the staging environment. We can basically even copy some suggestions. So we have even some commands we can actually copy in order to have a look at what's going on. So this one, so the output doesn't look so awesome, but still gives us a bit of information. So we can see, for example, that the pipeline at least is running. So the repository has been pushed to GitHub. And basically, a webhook also has been registered. Jenkins is notified and is building already our microservice. So we didn't have to generate any Docker image. We didn't have to generate any or try to tune any Kubernetes manifest or other tools. So it's pretty powerful. And here we can have a look at the Jenkins build logs, for example. So, and at the moment, so pipelines are the same. There's another command, jx get applications. But at the moment, actually, the application is not yet deployed on staging. That's why we just see my, let's say, backup demo application. Soon it's going to be also deployed on staging, and is going to basically be displayed also here. The same stuff we have seen in the console, we can also, of course, we can have a look at it on Jenkins itself. So as you can see here, the pipeline has been started. And Jenkins is already configured out of the box with the Kubernetes plugin, so that basically we are using some master-slave architecture with the normal Jenkins application as a master and an elastic pool of containers, let's say, as slaves in order to build your code. And there are a bunch of different containers according to the language and the framework and the build tool you are using. So here it's actually going to take, normally takes between 5 and 7 minutes to completely build an application. Tag it, because here we use trunk-based development. So basically every commit on the master or every pull request which is merged on the master is a release. So Jenkins X is here in the, probably is a bit too small, but I can increase it. So here make tag is just calling the old make stuff in order to generate a git tag and a release. Here we can see the typical command Maven is basically building and testing the code. It's up to us, of course, writing a nice unit integration component, contract testing, end-to-end tests. This is basically the basic workflow. So we can now, in the meanwhile, it's going to take a couple of minutes still, we can a bit explore what has been generated by Jenkins X. So I am in the right folder here. So I recommend using, for just simple stuff, Visual Studio Code, because it's also nicely integrated with Jenkins X. And as you can see in the bottom left corner, there is even a Jenkins X plugin for Visual Studio Code, as well as also has IntelliJ. So you can, all the stuff I have been showing you from the console, you can do that also with just a few clicks. So you can see the staging and production pipelines on Jenkins. And you can see our application, master branch. There is this kind of small icon, which means it's building. If we check the already deployed one, so we can see there is some kind of green light. So we could even start pipelines from Visual Studio Code. So I think it's a pretty nice integration. So now what you can see here is a typical simple Spring Boot application. What is important to see, so basically Jenkins X is using Draft. Draft is a nice tool which allows us to figure out which kind of language we are using, which kind of build tool we are using, and is going to generate according to some templates which are provided out of the box, but we can even customize them and provide our own ones. At the moment, I'm just using basically the default one. So it's generating a Docker file. And here, it doesn't look probably really the best one, but I think soon they are going to approve my pull request. So first of all, okay, as normal Docker file, we have a base image, and for running services, we don't need a JDK. We just need the Java runtime. So that's one pull request I submitted. Then here we are using Java 8, but Java 8 is not aware of C groups. So with C groups, it's basically a functionality of the Linux kernel with which you can assign resources to processes. So in this way, basically, you can limit the amount of CPU and memory you assign to a container, to a process. And unfortunately, Java 8 and 9, so out of the boxes, there is basically, the JVM doesn't see the container. It's just trying to eat up all your memory as much as it wants. So you have to basically activate a special flag in order to recognize the C groups. Luckily, Java 10 solved this problem, so Java 10 applications are Docker aware, let's say. So I should even have my pull request. Okay, there is even something more, but not so important. So it's also basically related to the startup problem of Spring Boot applications on Kubernetes. So just important here is this line over here. So here I'm just using some flags in order to use the C groups, so that the container is basically, so the JVM is basically aware is running in a container. And I also try to increase a little bit the resources which the Cloud Bees, the Jenkins X guys, are basically providing by default. So here I just allow the JVM to burst a little bit during the startup phase, is allowed to eat up a little bit more resources, and that's it. And then, yeah, the other one, the other pull request, hopefully these guys are working like crazy. They're doing really an amazing job, so they're pretty busy, of course. And here you can see I'm suggesting to use the JRE Alpine, also because it's smaller, so we pay less for our cloud providers. And also we have, it's better for security reasons because we have less, let's say, security risks, less code basically. And it's also smaller. So not only you can save money on network usage, but it's also faster, even though everything is running in the same virtual network on the Google Kubernetes engine, basically. So let's go back to Visual Studio Code, so to our application. So this was one file. Then we have the Jenkins file. The Jenkins file is just a default which allows us to build our Spring Boot application. We have a multi-stage build. First part is related to pull requests, so feature branches which want to be merged on the master. And the most interesting is actually related to the master. Every time we commit something to the master, this pipeline is going to be executed using a container which is specified at the really top. So at the moment we are using a Maven container, so it basically is packing everything so that it can build a Java Spring Boot application. And it's not just this bunch of files. We have also a scaffold manifest. So scaffold is a tool developed from Google, if I'm not wrong. And they're basically trying to abstract the way how we build Docker containers. So basically, we could use the local Docker daemon if we are working locally, but we could even use cloud providers builders like the Google Builder, Google Container Builder, or some other ones. And also, it takes care of pushing these Docker images to the appropriate Docker registry. In our case, we are hosting ourselves the Docker registry, but you can use also, for example, the Google registry. And the scaffold is also pretty cool because it allows to basically to always, as soon as you change some code, it's going to rebuild the Docker image and push it to Kubernetes. It's also pretty cool. Then we have also generated chart folder. The most important one is basically has the same name of the application. So here we have just a bunch of Kubernetes manifests packed into an Helm chart, and we have some default. So we define everything has been already generated for us. So we have a Kubernetes deployment with a lot of configuration parameters, which are taken from a value file. So you can basically tune a lot of parameters. For example, we could change the replica count. So if our microservices is under heavy load or before Black Friday, we could, for example, scale and we could increase the number of replicas. Or if we are really, let's say, advanced, we could even set up auto-scaling according to the traffic. So this is basically what has been generated for us by Jenkins X. Now, let's have a look, hopefully, the pipeline from JX GitHub. So here I can see, well, it means it's green. So we can see the JDD application deployed already on staging. So by default, as a semantic versioning, we're using 001. But I mean, you can change it as you wish with git tags. And here we can see we have just one replica running on Kubernetes, and we have the URL, so we can already reach our application. Of course, it's going to look pretty bad because this is the default Spring Boot, let's say, landing page. But just to show, for example, there is no cheating. We can call the actuator, and we can see, for example, I can call some health checks. Just it's going to reply, yeah, I'm running. And this is going to be used by Kubernetes in order to know whether the application is running properly or not. Then you have some other information. At the moment, it's just empty. We're not providing anything special. Okay. And of course, we can always go back to Jenkins and we can see the pipeline is green. And how did the deployment, how was it carried out? We said about GitOps. So during the build of our JDD awesome Spring Boot microservice, basically a pull request has been triggered on the staging Git repository. So for example, here we can see pull request number 3, for example, has been opened 8 minutes ago. And if we just go back to GitHub, we have the JDD awesome application, and we can see on staging. Now it has been already, it was pretty fast, so it has been already closed. And you can see here we have a pull request which has been automatically triggered by Jenkins X. And there is no rocket science here. So it's just saying, I want this application from this repository, this version, I want it to be deployed on staging. Same stuff is going to be for production. After merging the pull request, basically, we have a second pipeline. And that's what you see here, basically. So this is the pipeline in order to actually deploy the application into Kubernetes. First of all, we validate the application, the helm chart, and then we just deploy it. Everything has been green till now, so I'm pretty happy. Now we can go back to Visual Studio Code. And here, for example, now let's suppose, okay, we have a default application. We want to add some feature. So I integrated also, just in order not to switch every time through the console, Visual Studio Code, and back and forth. I also installed the new the GitHub plugin, including the GitHub pull requests. So we can even review, we will have a look at it. We can even review code directly on Visual Studio Code. So here, for example, hopefully it works. Not really. Otherwise, yeah, let's go here. We can basically so this is our new feature branch. Okay, so we can basically just ask REST. That's why it was not working. Some point probably will work again. Let's see. Yes. Cool. Even these guys make some mistakes. Okay, so we have just the Spring Boot application starter. Here, I will just extend this class, even though it doesn't, basically is not compliant to the single responsibility principle, but it's just a demo. So let's create a really super simple endpoint. So, and maybe we can even say, yeah, path variable. And then we just say, we return an hello message. Okay, so we have to map this stuff. If you see any mistake, just correct me. No problem. Hopefully now should be fine. Okay, so we can basically, I think this guy is not seeing my changes. Okay, now, so let's just commit and push. Let's see if it works. here. It's pretty new, so. Okay. So now my branch should be, with the changes, should be basically on GitHub. Let's have a look. Okay. And I could generate a pull request directly from GitHub, or I can use Visual Studio Code. So I can basically generate a pull request, to the master. And this is hopefully going to generate a pull request for me. Nice. I can open it on GitHub. Okay. So pull request number 1 is here. We can, of course, start a lot of debates and fights about code quality standards. Sometimes it happens in a few themes. So we can review our code. And it's pretty nice. We can, from I think just 1 month or something, we can even review code within Visual Studio. So it's also not bad because you review code directly in the IDE. I don't know if something like this is existing for IntelliJ, but in case not, probably it's going to also to be developed soon, I guess. Of course, at the moment, so I can see the description as well, but I cannot approve it because I generated a pull request, so I think it's still a bug in this case here, but it's pretty cool. So if we are satisfied, we can basically merge the pull request into the master. But there is something really interesting happening here under the hood. So let's see the environments. They're still the same, but now, for example, if I just go to Jenkins again, we can see a pipeline should have been started for my pull request. So what I committed to the feature branch is basically now validated, just a normal Maven install build. But the cool part is a dynamic sandbox, let's call it in this way, is going to be dynamically generated. So basically in Kubernetes, what's happening, we just have a pod which is started and in a different namespace. And actually, we can already even test our application before merging it to the master. That's also pretty cool, especially if you are dealing with front-end changes, maybe, or you want to see the REST APIs. You want to see how the response looks like. So now what you can see, for example, or probably, yeah, you can see here, make preview is basically creating this preview environment. And the cool part, you can configure the preview environment from the Helm chart. So even the preview environment, here you can see a folder, preview, and here you define your preview environment. So at the moment, it's just space R coding, basically the dependency from the application. There is nothing more, but you could, of course, taking care of security issues. You can even connect this pod to a staging environment because maybe you need some real data or even to production. I wouldn't recommend that probably, but with the proper configuration, it's possible. So now, the cool part is if I go back to my pull request, Jenkins X is writing a comment here that preview environment has been generated. So I can click, basically, and access this preview environment. So we created a new endpoint. Let's say JDD, hopefully, yeah. And response is hello JDD. Now, if we are happy with the code quality and also with the result with the preview environment, we can, you have to find it again. Yeah, we can basically now, if we are happy, we can merge the pull request. Now, as soon as we merge the pull request, a new pipeline, of course, is going to be triggered on staging, and the application is going to be deployed again on staging. So if we go to our JDD application, a new pipeline has been created. Now, this is going, as before, as the really beginning, is going to take 5-6 minutes. So in the meanwhile, actually, I would like to show you something else. So now we have the application on staging, but we don't have the application on production. So basically, so first of all, I would like to go back to the master. Okay, so there is a nice command, JX promote. And here you can specify which version, for example, the really first one, which environment on production, and the application. Well, it should be actually default, but sometimes a few commands, these are new ones, they're a bit shaky. So I would like to, anyway, to be precise. Otherwise, there should be also an interactive command line, but sometimes you get a few errors, which normally are fixed really fast. So here I can just say, yeah, I want to promote it to production. So what's happening here? It's going to ask me if I want to generate a pull request, because we are using GitOps, yes. So here we create a pull request. We can already jump to it. And here you can see the change is just, yeah, we want this version on production. The cool part, you can reduce the mean time to recover, because in case of a problem, which shouldn't happen if you have a really complete and extensive quality checks, basically, and testing in the pipeline, but sometimes it happens, so you can easily revert. So now, of course, this is going to take, normally takes like 1 minute, but actually now we promoted the application using the JX promote command. I wouldn't recommend it, actually. I would create directly a pull request, in my opinion, because here, this one is actually gonna be merged without review. So I think it would be better just basically adding this line or changing those lines with the normal editor, even a text editor. Then you can submit a pull request. Someone is going to say, yes, it's right, and you can deploy basically on production. Yeah, that's basically the introduction to the demo. So just have a few minutes left. But so what I would like to add here, Jenkins X, like every tool or framework, is no silver bullet. For me, it's the most important stuff is communication in a team. Never stop learning and never stop sharing. That's sometimes I see people just being scared of asking questions. There are no stupid questions, in my opinion. So this would be actually also my take-home message. So I would appreciate if you rate my talk. And yes, do you have any questions? Okay, the question was, how do you handle upgrades of Kubernetes? So basically, Jenkins X is evolving pretty fast. So, okay, here it's doing some nice stuff, but okay, still promoting on production. It's a bit slow here. Okay, let's take this window. So you have JX upgrade, and here there is the nice -- help flag. And you have different type of upgrades. You can upgrade the command line tool, you can upgrade the Kubernetes cluster, and you can upgrade the Jenkins platform. Probably it's a bit too small. I hope you can see a little bit better. So here you can upgrade the command line interface. And normally there is always a new version. I'm sure if I do JX version, probably, even though I updated that this morning or yesterday evening, probably there is even already a new version. Let's see. In case it's going to ask me, do you want to install this version? Yeah, probably network is not super fast, so here there is a small problem, but some network issues. But anyway, it's going to ask me if I want to upgrade the platform. So you can decide what you want to upgrade. Here it is. So here, for example, it's asking me if I want to upgrade the command line interface. Or so you can take care of this stuff like this. And also something that is being integrated is also Terraform. So at the moment, as you have seen, we had one Kubernetes cluster with everything on it. I think it's create Terraform. And so you can even create a Terraform script in order to also generate different clusters. For example, some customers, they want production or staging as different clusters. But yeah, as far as I know, so the guys, they are still working on it. So it's a bit shaky. So that's why also I didn't really show that in the demonstration. Any other question? So in case, So Jenkins X is open source. And so I'm myself trying to contribute. And you have full access to the code. The model, so basically there is this nice also command, JX create add-on. And here you have also a bunch of add-ons you can install. Here, for example, you have this one, CloudBees. And CloudBees is going to monetize this open source project with the graphic user interface. So everything you have seen now, a bit jumping from the console Jenkins, is going to be possible soon also with a nice GUI. And you have even many more stuff. So you can have Knative builds. You can install Istio, so as a service mesh. You can either verify container images for security issues and either perform dynamic security checks against running apps. And as far as I know, so there is also, so the development is pretty fast. They have even the cool functionality that maybe you can, as a homework, you can check it. I think I have this page already open. So there are the dev pods. Dev pods are just Docker containers, and instead of working on your local machine, you can just open the browser, open the TIA IDE. I think, this one. It's basically a cloud-based IDE which works on every browser. So you can even, so there is no basically setup phase. So you could even directly work on the cloud. That's also pretty cool. Or you can use Visual Studio Code, and in the background you have basically a tool which is just synchronizing the code from your local machine and the Docker container running in the cloud. It's pretty awesome. So, other questions?
Thank you. Do you know if there is a hosting service for Jenkins X so that you wouldn't have to do anything locally? Just
you mean some kind of, let's call it, Jenkins X as a service?
Yes.
Mm-hmm. As far as I know, not yet. So at the moment, you have to install that on your public or even private cloud, but you have to install that on your own on the Google Cloud or Amazon. It's also, since a few months, is also providing managed Kubernetes cluster. That's also what I would recommend. So setting up Kubernetes from scratch probably is not as difficult, and it's shaky. So I would say I would go for a managed version. And at the moment, you have to do that using Terraform or using the Jenkins X command line tool. So then, thank you for listening.